Okay, welcome back, gang. We're going to jump up another dimension in our geometry work here, and we're going to change from the area inside of a flat space to the area inside of a three-dimensional space. So if you can think about how much fuel would fit in that tank, that is a measure of volume. Or how much air and fuel there is inside that cylinder, that's a measure of volume. The key is we're popping into three-dimensional shapes instead of just flat geometric figures. So yeah, volume is just a measure of how much space is inside of an object, whether it's solid or empty. And the simplest shapes to find the volume of are rectangular solids, which we often call boxes. What you see at right is a typical fuel tank that might fit in the back of a pickup truck, and our goal is to figure out how many gallons this would hold. So in general, a box like this one, all we need to do to find the volume is multiply the length by the width by the height. So in this case, that's going to be the length, which is 42 inches, by the width, which is 14 inches, by the height, which is 8 inches. Take out your calculator. Don't just watch me do it, but take out your calculator and verify that. You should get 4,704 when you multiply those three numbers together. Now, this is volume, and so these are no longer square inches. These are cubic inches, inches in three dimensions. Now, we want to find the volume of this tank in gallons. This would be on your gold conversion sheet. By the way, I posted the conversion sheet online so you can access it. You should have gotten a message about that. But from your gold conversion sheet, it's true that 1 gallon is equal to 231 cubic inches. So let's do that conversion. 4,704 cubic inches over 1, and 231 cubic inches make up each gallon. That makes the units cancel. And when you divide that, you get 20.4 gallons. This would probably be sold as a 20-gallon tank, allowing a little bit of room for air and fuel expansion. Okay, that creates a kind of an interesting scenario. When you think about the amount of concrete we put into roads, it's a phenomenal amount of concrete and therefore a phenomenal cost to get done. But let's crunch the numbers on this. The interstate highway system has specific requirements for the construction of the interstate roads. The concrete in roads has to be at least 11 inches thick to handle the heavy weight that they have to carry. They have to be at least 12 feet wide to accommodate wide loads. So let's figure out what the value of the concrete is in just the eastbound section. That's the two lanes that head towards Toma from Onalaska, and that distance is about 39 miles. So we're going to do this in two parts. Let's first of all just picture this shape. This is a big old slab of concrete, but it is more or less in the shape of a very, very long box, like that. And if you want to picture it, there'd be some stripes down the middle between the two lanes. We're not including the shoulders. Those are usually blacktop instead of concrete. But if each lane is 12 feet wide, then we know that the two lanes must be together 24 feet wide, and that would be the width of our rectangular box. And of course that's true since each lane would be 12 feet. Now, the height of this box is only 11 inches. So our units don't match. We need to make them match. Let's take 11 and divide it by 12 inches per foot in order to turn this into feet. And if you divide that, you get 0.917 feet, and that's the height of our huge concrete slab. And of course there's some curves in that, but we're going to ignore that. And finally, the length. The length is 39 miles. So if we take 39 miles and convert those into feet so that all of our units match, we saw earlier that a mile is 5,280 feet. That conversion is on your sheet. Then that becomes 205,920 feet long. So then we can find the volume of that huge slab of concrete. The volume will be its length, which we just saw was 205,920, times its width, which is 24 feet, times the thickness, which is 0.917 feet. And again, the key there is that we're putting it all in the same units: 24 feet wide, 205,920 feet long, and 0.917 feet. Whenever we use a geometric formula, all the units have to be in the same unit of measure. So if we multiply that, we get about, and I mean about because if you round off those feet a little bit differently, you're going to get a little bit different value, but about 4,531,000, about 890 cubic feet of concrete. That's a lot of concrete. Now let's figure out what the value of that concrete is. Let's take that measurement of 4,531,890 cubic feet and do some conversions here. Let's put that over 1. We know that concrete is around 110 bucks per cubic yard. They're probably getting it cheaper since they're buying so much, but that's about what you or I would pay. Conversion fact, this is on your gold sheet, or again, you can consult the one that I'm going to post online. There are 27 cubic feet for every cubic yard. That's because there's 3 feet in a yard, but that gets cubed, and 3 cubed is 27. And then we can treat the price as a conversion fact. 1 cubic yard of concrete is worth $110. And what you get is about $18,463,000. So just in the eastbound lane, there's between $18 and $19 million worth of concrete. It's no wonder that it costs so much to do road repair. Okay, our second general category of shapes beyond boxes that we just saw is the category of a prism. A prism is any three-dimensional shape that have matching ends and parallel sides. So here's a few examples of a prism. This one we would say is a pentagonal or pentagon prism because the ends, the top and bottom, match, and all of our sides are straight up and down. A cube is an example of that because the ends, the top and bottom, match, and the sides are up and down. Here's what you usually think of when you think about a prism. Triangular prism, the ends match, and the sides are up and down. So to find the volume of a prism, we need to know the area of the base. That is our capital B. I like to call that the footprint. We have to find the area, not just one dimension, but the area of that bottom, and then we multiply it by the height. I like to think of that as being kind of like an apartment building. If you have an apartment building, and you know that every level of the apartment building has 10 apartments in it, and you know that this apartment building has 7 stories, you can tell me how many apartments there are in the whole building. There's 10 on each floor times 7 stories, so we know the first level and we know how high it is. That would be our capital B, that would be our height. The volume of this building then is 1 floor, 10 apartments times 7 stories. You'd have 70 apartments. And that's the principle that this is based on. Let's look at an example. Okay, this is kind of an unusual tank. Years ago, one of my friends sent me this picture. He'd seen it online. Somebody was welding up this fuel tank for a street rod they were building, and he wanted to know how many gallons it held. I've changed the problems to liters just so we have some different math to do. But here's what we're going to do. We have to figure out what the area of that end is. That is our capital B, and we'll find the area and we'll find the volume if we multiply the area of that end times the height. Now we already know what the height is. The height is 38 inches. So we have to figure out what the area of this end is. So I'm going to lay that tank down and draw it in a little different way. If we lay that tank down, it's going to look like this. That's how it would actually sit in the vehicle. And for perspective, that 12 inches is down here. That 14 inches is back here. That 6 inches is actually the top. And the 38 inches is how wide the tank when it lays on its side. Okay, so we need to find what the area of this end, or what the base of this prism is. So let's do that by breaking this in half. The left side of this is a rectangle that is 6 by 14. 6 by 14, that is 84 square inches on the left side. The triangle on the right, if that's 6 inches, this must also be 6 inches. And so the area here must be base times height divided by 2, since it's a triangle. That is, that's 6 times 14 divided by 2, and that gives you 42 square inches. So if we add those together, 84 plus 42, that means the area of this end must be 126 square inches. So we can go up here and say that the area of the end of that tank is 126 square inches. That is the value of our B. So our volume then, which is the area of the bottom times the height, our volume is 126 square inches times a height of 38 inches. That gives us a volume of 4,788 cubic inches. Now that solves the geometry part of this, but let's convert that into liters. So 4,788 cubic inches, let's put that over 1. Now to find a path to get to cubic inches, and again your conversion sheet will be useful here, but we know that 1 cubic inch is 16.39 cubic centimeters, and we know that 1,000 cubic centimeters is 1 liter. So let's use those two conversion facts. 1 cubic inch is 16.39 centimeters cubed. That cancels those off. And we know that 1,000 cubic centimeters is 1 liter. So now you can reach for your calculator, and when you multiply that, you get about 78.47 liters, and we've answered the question. That is the approximate volume of that tank. Okay, well, one category of prism is a cylinder. A cylinder is just a prism where the top and bottom match all right. The top and bottom of a cylinder are both circles. But the bottom of that shape is a circle, and we know that the area there is pi times the radius squared. So if we multiply that by height, we get another formula, and that is to say the volume of a cylinder is pi times radius squared times the height. So let's figure out how many gallons this tank holds, this barrel I should say. The diameter is 22.5 and the height is 33 inches. Okay, well we need to know the radius of this, and so if the diameter is 22.5 inches, then the radius is half of that, or 11.25 inches. So to find our volume, we can say that pi r squared times height, in this case, is 3.1416 times 11.25 inches squared times a height of 33 inches. And we get 13,121 cubic inches. There's some decimals on there, but they're not going to matter too much. 13,121 cubic inches. Now, let's turn that into gallons. That's a pretty straightforward conversion. We know that 1 gallon is equal to 231 cubic inches. We've used that one already in this section. So 13,121 cubic inches divided by 231 cubic inches per gallon turns out to be 56.8 gallons, which makes sense because this is actually a 55-gallon drum, so a little bit of airspace in there. A 56.8 gallon drum, we've settled that. Okay, this is also how you find engine displacement, because every cylinder of an engine is the exact same kind of cylinder as that barrel that we were just working with. So let's figure out what the displacement of this inline 6-cylinder engine is. 1, 2, 3, 4, 5, 6 cylinders. Let's start by finding the volume of one cylinder. So the bore is 4.020. A bore is just another name for your diameter. That is the distance across. So 4.020 inches across that cylinder, and our stroke, that's just another name for the height of the cylinder. And so that is 4.720 inches. Okay, since this is a cylinder, we can just say that the volume is pi times the radius squared times the height. Since our bore is 4.20, we can conclude that the radius must be half of that, or 2.010 inches. And so our volume is pi times 2.010 inches squared times the height of 4.720, and you will get 59.9. Now all those units were in inches, so our units are cubic inches. That's for each cylinder though, and there are 6 of them. So let's multiply that by 6, and that gives us a displacement of 359.4 cubic inches. Now in our next section, we'll convert that into liters and cc's, but that's good enough for now. Okay, I want you to pause the video for a minute and tell me what the displacement of this engine is. This is a V8 engine with a bore of 4.03 and a stroke of 3.48. Use your phone calculator or your regular calculator to compute that. Unpause the video when you've got your answer and want to check it. Okay, here again, we've got a cylinder. Let's figure out what the volume of one of them is. The bore is 4.03, that is our diameter. And since the bore is 4.3, we can conclude then that our radius is half of that, 2.015 inches. Our stroke is 3.48, so that is the height of our cylinder. And then we're ready to compute. We know that the volume of this is pi r squared times height, since it's a cylinder. And that means our volume is 3.1416 times 2.015 squared times our height of 3.48. I guess I'm running onto the engine there a little bit. Sorry about that. Times 3.480 inches, our height. And that gives us a volume of 44.39, those are cubic inches per cylinder. But again, this is a V8 engine, so we're going to multiply that by 8. And if we do that, our displacement turns out to be 355.1 cubic inches. And again, I'm rounding to 1 or 2 decimal places, which for volume calculation is fine. It really doesn't matter that much. Okay, here's our last shape, and is the volume of a sphere. The volume of a sphere is kind of unique in that there's only one dimension we need. For a sphere, the only dimension we need to know, or a ball, of course, a sphere is the same as a ball, is the radius. So we take that radius and we cube it, multiply by pi times 4, and then divide by 3. Most of the time, we're going to be working with spheres. It's going to be a hemisphere, though, because hemispheres make up the ends of tanks and combustion chambers, like we're going to see. So here again, the only dimension that we need is the radius. And so if it's a hemisphere, we'll divide the volume of our sphere by 2. Make sure you jot down that formula, and then we're going to do one last example. Okay, a Hemi engine is called a Hemi engine because the combustion chambers in the cylinder head are hemispherical. So if you want to think about it, those combustion chambers where the valves are half of a sphere. Now the diameter in this case is 10.5 centimeter. So since that's the diameter, we can divide that by 2, and we get a radius of 5.25 centimeters. And so that would be our dimension here. The volume of an entire sphere is 4 pi times the radius cubed divided by 3. But if we're only dealing with a hemisphere like we are here, our volume is going to be 4 pi r cubed over 3, but we're going to divide that by 2. So let's crunch that. Our volume here is going to be 4 times pi times our radius of 5.25. Now be careful, that needs to be cubed. I want to make sure you type that into your calculator. That's really 5.25 times itself 3 times, and we're going to divide that by 3. Go ahead and do that in your calculator. Make sure you start with the exponent. 5.25 times 5.25 times itself 3 times, then times pi times 4 and divide that by 3. If you do that, you'll get 606.13. Now all those units were centimeters, so those are centimeters cubed. But this is a hemisphere, and so we need to divide that by 2. So split that in half, and we get 303.07 centimeters cubed. And that is the answer to our question. Now make sure that you do that in your calculator or phone and get that same result. Okay, that wraps up our topic on volume. And again, to summarize, there's a few formulas you need here. The volume of a sphere, you should have that written down. You should have the volume of a cylinder, pi r squared times height. The volume of a prism, that is the area of the base times the height. Make sure that you use this when you make a note, that it's not just one dimension, but it's the whole area of the base times its height. And of course, a plain old box. Volume is equal to length times width times height. Those are the common shapes that are handy to know, and that's where we'll stop.